Okay, so you can see my screen, right? Okay, so you can see my mouse movement. Now let me open up this PowerPoint slide. So this was your homework. I was talking about the convert this to relational model. So this is vendor, order. There's no difficulty, just one-to-many here. And then there's a gerund here. So basically, you need to primary key duplicated from orders into order item, items into primary key for items into the order item. So basically, the order item is going to have two foreign key columns, SQL and order number. And they both will be part of primary key for this order item, right? So there's nothing special. And then they have one-to-many relationship between category and items. So you duplicate primary key for category into items. So that's not difficult. Now we see we have department, and then we have checkout, and then we have this so-called this is gerund. So that part is so basically it's a weak entity. A department checkout is like a weak entity, depends on the strong entity, which is department. Okay, and then we have like a gerund here. So let's try to do this one. Okay, I'm going to do this one only. So I'm going to skip all this part. Okay, so we use let's do that's it. Okay, so let's do whiteboard. I'm going to pull this up here. Oh, and the whiteboard. So, I mean, all right. So let's try to do department, checkout, and the checkout items. Okay. So first of all, relational model. You're going to have a department table. And that table is going to have just two columns, department number and department name. Department number, department name, which is optional. Department number is ID. Then you have a checkout. Checkouts. So checkout table have a transaction ID, transaction date, and the made by. So, transaction ID, which is UID, not really, but it's partial UID, so we'll just underline it first. And then transaction date, so let's just say T date, okay? Which is optional. And then made by, transaction made by whom? That is also optional. Okay. And then next one is checkout item. So that is a line item actually. Check out item. And then for that one, you're going to have quantity and unit charge. QTY, optional, unit charge, also optional. And then of course, to get that, you have to have items. So I'm going to put items here. SKU as ID. And then description, minimum quantity, maximum quantity, EESC, all of them are optional. So min, max, quantity on hand, over here. All right, and then color size. Size. All of them over here. Okay. So we'll just skip other things. Just handle this 1, 2, 3, 4, 4 things. Okay. So the first thing you want to do is make sure you handle weak entities. So weak entity between department and the checkout. The checkout is a weak entity, so you're going to duplicate primary key from department into checkout. So basically primary key from here to here. So I'm going to create so that maybe call rename as department, let's say department, and that is foreign key duplicated from here. Okay, and that foreign key will be required because if you look at the side, look at here, the side is solid line, right? So this is required. So that's just a one-to-many relationship, regular one-to-many relationship. However, you notice that little bar here. So then we are going to make that as a part of primary key here. Okay, so that means the checkout is going to have a primary key consisting of 2 columns, transaction ID and department, 2 columns. Okay, and next, let's handle everything else. So basically, you're going to have this gerund handle. So there's a one-to-many and there's a one-to-many. So you're going to duplicate primary key from items into checkout item. So items, this one SKU is going to be duplicated here. So I'm going to put it here. So S K U. So that is foreign key, and that foreign key is always required because the junction table, because of a gerund here. So this is solid anyway, and that is solid here. And that is duplicated from here. And now you look at this little bar here. That means that foreign key, this little bar, this item to here. This little bar, that means that foreign key is going to be also a part of a primary key. So let's underline that. Okay. And the next, you're going to duplicate the primary key from checkout into here too. So remember, primary key for checkout consists of transaction ID and the department, both 2 columns. So you have to duplicate those. So you're going to have TID and DEPT, both columns. Okay, and there will be, you can look at here, this line is a solid line. And that means both foreign key columns are required. Okay, now who can tell me how many foreign keys that this checkout item have? 2, exactly. So it's not a 3. If you say 3, that would be wrong. Why? This is one primary key duplicated, and this one all together, it should be all together count as a 1 foreign key. Okay, so that's why this table has just 2 foreign keys. And then because of this little bar, if you look at this little bar here, that means that should be also part of a primary key too. So primary key. So this checkout item, line item, is going to have like 3 columns as a part of a primary key, right? Okay, so now let's say besides that, basically, I think that's everything else should be okay. So if you put a category, create category, then category ID in here, and then the rest I will explain. So now let's try to, I think you need to write SQL statement too. So let's open up SQL developer to implement that. I'm going to log in. So let me put this aside. Now this. Let's do create tables one by one. So first table without foreign keys. So that would be table departments. So create table departments. This and the D number. Department number, let's just say it's a number, maybe 3 digit. Okay. And then department name. So let's just say that would be Chow 25, which is optional. Say Chow. Okay. So we'll leave that now. So we can have a not null for D number, but actually because that's going to be part of the primary key, so it does not really matter. Okay, so next let's create a constraint. So constraint pk, and then that will be dept constraint. Okay, and then primary key, which is D number. Okay, so that's everything. And now with department, we are ready to do checkouts. So let's move checkout up. So we're going to do checkouts. Create table checkouts. So that has transaction ID. So for that, let's just say I want to put a number, which is pretty big integer. Okay, it's going to be not a null, but it's going to be part of it. UID part of primary key, so we can just split that. And key date, which is data time, right? Date. And then made. So usually this is some kind of username. So let's just say that's a assuming that we have 42 characters for users. This is not null. And then DEPD here. DEPD is actually representing department number, but its name has been changed. So we have to have a by following first referential integrity rule, we have to make sure that number type size type must match. So we have to use number 3 here. Okay. So that's foreign key count. That's it. And now we can create the primary key for foreign keys. Constraint pk. And then this is for check out. Primary key. The primary key in this case is TID. TID and DPD, right? Yeah, those colors. And then we have a constraint fk, let's say CO. So the foreign key, the primary key is coming, the department is coming from department number of departments. So we have a reference to the DEPT table. So foreign key, and then that is DEPT references, the member table from which you get the primary key duplicated, departments. Okay, so that's it. That's the last one. So let's close the deal. Okay. And now let's do items. So we have to do items before we can do this around. Create table items. So items have SKU. That would be typically char, let's say 14 letters. And then description. And the description, let's just use a vocal. So usually vocal is a standard data type, but we'll use vocal too for Oracle. Oracle has an optimized version of vocal. Let's say the number of description is say a couple of hundred letters, maybe 200. Okay. And I explained to you that If you use say child 200, then regardless how long is the description, our database is going to give you 200 characters for as a fixed. Okay, so even though your description maybe have like a few letters, but it will give you 200. But when you use vocab or vocab 2, then the maximum is still 200. However, if your actual description is very small, like few hundred, like a few letters, then a lot of spaces can be saved. Okay. So maybe say if your description has only 10 letters, then you have 190 letters can be saved for other purposes. So that is of advantage of using vocab. So mean quantity, that will be just some kind of a number. So let's just say quantity is some kind of decimal numbers. So I'll just do maybe 5, 1, right? Minimum quantity. And the max quantity is also just imagine there's some kind of 7, 1. Okay? That's optional. And then quantity on hand, QOH, is also a number. That should be 7, 1 by default. So maximum size, number of digits, maximum integer number of digits is 6. The decimal place is 1. Okay, that's what 7. And then we're going to have column size. Column, let's just say that's a chart, maybe 15 characters. Size maybe depends on cases. Maybe just in general, it's just a chart. Okay? 15 characters or 10 characters, whatever. All right, so this table has only one primary key constraint, PK items. Of course, if you implement the whole thing, then you have to have a category ID as a foreign key, but we're going to skip that. Primary key, and that is SKU. And this is last one. Close. Okay, finally, we can go ahead to do checkout line item, checkout items. Create table, checkout items. Checkout items. And then we move this up. So that one has usually how many columns? To move this up. Okay, so we're going to have checkout items. First of all, you're going to have SKU. And that is a foreign key coming from item. So make sure that is matching this SKU. So the child 14. Okay, this is going to be not null by default. Then part of the primary key. And then you have quantity. So let's say quantity is a number. So it depends on typical size, like 3, 1 is typical auto size. And then unit charge. And the screen size is very small. And the unit price. So let's just say that's typically a number. Let's use 5, 2, 2 decimal places for unit price, unit charge, unit price, unit charge, doesn't matter, okay? And then we have TID and the DPT. TID, and that is coming from checkouts. So make sure you're matching that. TID is from here. So it's number 15. Okay, and then another one is DPT. DPT is also coming from the checkouts. DEPT. from checkout. So remember in checkout, you have remember that as part of number 3, which is actually originally from department, right? So basically it's message just like a chain effect transition. So we to follow that same data type. Okay. Number 3. Okay. So now we are ready to implement the constraints. So first one is primary key constraint PK, and that PK is check out item, which is okay. Primary key. So this primary key actually consists of 3 columns: SKU, TID, and DPD. All 3 columns. And then we do foreign keys. We have 2 foreign keys. FK, COI. The first one reference to the item. And that foreign key is SKU. References items. Constraint FK, COI. And this one is from checkout. And then foreign key. And this foreign key is coming from checkout. So basically you're going to have 2 columns here. So TID and the department number. So TID. References. And then let's say that's checkouts. Okay. Now I purposely made a mistake somewhere in this table. Can somebody point out what is the mistake? Anybody? I had a mistake in this table. Not a small mistake. It's actually a very serious mistake. So a serious mistake like a referential integrity rules violation. That's a very serious mistake.
Can you have 2 items for the foreign key, the department and the transaction ID?
Yeah, you can have two. You can have two columns as a foreign key. Yeah.
Okay.
Because that was a primary key, right? That was one primary key duplicated.
Well,
If your primary key has 3 columns, then you have to duplicate all 3 columns. If your primary key has 2 columns, you duplicate 2 columns. Yeah.
You haven't. Never mind.
Just speak up. It doesn't matter. Don't be afraid. Anybody? Okay. Now, what was the primary key for checkouts? I said TID department. Now, what is the foreign key? Do they match? Does everybody say that? They do not match.
So it has to be in order?
Yes. It has to be exactly the same order as original. And this primary key and going to be mapped to these foreign keys. Okay? Column by column, row by row. Column by column. Yeah. So this is wrong. So you have to say in the original primary key, you make TID first, and you have to do TID first too. Okay, so that was a serious mistake. All right, so we are ready. So basically, I think we can create those tables. Let's just try to see whether we can do it. Data 1, data 2, data 3. We have error. So can somebody point out what is that? It says which one is not valid identifier. So basically the min and the max are not, they are keywords. Yeah. DSC is also. Okay. So remember we said describe, right? Descript, DSC, that's the keyword. And then this is the min quantity, 21. And this is the max quantity. Okay. Size is also, okay. So size, how do we check this? Item size, maybe that. Okay. So the keywords cannot be used as names. Now table created, see that? Finally, table created, okay. So everything is fine, is right. Okay. Now, that means that this is part of it. This is like also a part of your homework. It's not a complete one, okay? Because we do not do every tables. And then let's say, let me look up the PowerPoint to see what we have done before. And let's see what we have not finished. Minimize that. I think that was this one. SQL. So we were trying to create a DDL, and we talk about referential integrity rules. We talk about this general database management issues, database management systems. What does it do? And we introduce the concept of the atomicity and the concurrency control. Okay, atomicity is just atomicity. It's autumn. It's not autumn. Atomicity. Atomicity and the concurrency control. Concurrency control is just make sure that every piece of data has like log. So only one person the log can be released to only one person at a time to make changes to the value. Only when that log is released, then second person can go ahead and apply the log to make changes. Otherwise, different users maybe just overriding each other's answer, overriding each other's change. So that will be disaster. Atomicity just say if a transaction has multiple steps, then just make sure they must be either all done completely or none of them done. Okay, so no transaction can be should be partially finished. So that is all important issue of database management. Because security and basically that's a privilege thing, right? So if you do not have privilege, should not have access to data, and especially should not be able to make changes to data. So that's all depends on the security privilege. Okay. All right, and then we talk about that. Let me see what else we need to do. We go to slideshow, start from here. I think we finished most of it. Okay, so we talk about that. And then for database, did we talk about that? Database connection. So basically you have two ways to make a database connection. So for that, the typical way is using TNS names, TNS names.ora. That file is located inside a network /admin subdirectory. Okay, and where is this file? The network, this network folder located. That is typically installed inside your Oracle products. So when you install Oracle server or client, then you're going to have a subfolder inside called a network. And inside that, you also have an admin folder. So inside the admin folder, you're going to have files like a listener. So basically, if you have server, then this listener file is controlling how your system is listen to which process, to which for which server and at which port. And then so this is controlled by the listener file. And then the other one is making a connection to other servers, the TNS names. So that you basically just have a list of description, list of so-called descriptions, and the description can tell what is the server's IP address or host name, and what is port number, and also what is SID, and that is built into that. So let me show you the file, the typical file method, file description. So basically, it's, for example, ecourse.org, that is just like a host string, and that host string will be connecting to this host, ecourse.org host. And the port number is 1521. And then this is SID. So remember, on one server, you can run multiple instances. And maybe on the ecourse.org, there are multiple databases, Oracle databases. One of them is called OL7.ecourse.org. Okay, so you're making connection to that. Okay, so this is a typical approach. So basically, if you're going to say you got a company, they use Oracle database, and then to be able to establish like a connection to the server, you need the 3 parameters: hostname, port number, and also this SID. And then you can just go to your computers, that particular photo, and then just trying to copy this description and change a bunch of the parameters. And then you'll be ready to make connections to your server. Okay. But if you use something like this, a visual tool like an SQL developer, you do not have to create that. You just simply use a basic description, basic connection type, specify host, IP, port number, and also a service name. And then this will build that description behind the screen. You want to be able to tell. Okay, you want to be able to save. So basically, this is just like a graphical connection approach. So it's much simpler. That's why we are using this one instead of SQL Plus, which comes from Oracle client. To install Oracle client is a little bit more complicated. So it's just worried that it might be confusing for a lot of students. So this is just like a shortcut to instead of using TMS names. Okay, we talked about how to create new users, how to change users, and how to drop users, right? And then we talk about how to implement a relational model using Oracle. So basically, we learn how to create a new table, okay? And then how to delete tables. So just the drop table, the name of table, okay? And then we learn how to list all the tables the user has. Did we do that? So for example, at this point, if I want to see what tables do I have, you just simply type command select table underscore name from user underscore tables. So remember, this user underscore tables is a table. That is a table. And that is called a meta table or system table. Okay, it's managed by Oracle database management systems. You do not have to worry about anything inside here. Okay, but you can query that. You can change. You can retrieve values from that. So one of the columns of the table is a table name. So here we basically say, show me that first column of this table. So this first column is all table names. So basically, every time when you create a new table, then the system will automatically add a new record to this meta table. And the first column, table name, will be just the name of the column which is created. So let me show you that. Run that. So, they run? No. Run it? Okay. So now you see that I have a bunch of tables created. The tables I just created a few sections ago was checkout items, checkouts, departments, right? So that show you what tables do I have. And then we learned how to look up a table structure. So for example, if I want to say what does the checkout item table looks like. So checkout items looks like, okay? And we just simply describe ESC or describe completely. So that table has 1, 2, 3, 4 columns. 5 columns, department table. Okay? So that's how we describe table structures. And that table does not have data yet, but if we want to say select everything from check out items. So this star just means all the columns from this table. Okay? And in this case, SQL, you have to use semicolon to end. But this one is not SQL. This is actually Oracle's SQL Plus command. It's not a SQL command. So for SQL Plus command, you have to end with semicolon. For non-SQL command, you can just you don't have to use a semicolon to end. So here I'm looking at entire table content of this table. Okay, so run it. So at this point we do not have any data, so it should be 0, should be nothing to be displayed. Okay, but just show the column has. Okay. All right. So how to list tables you have, how to describe the table structure, and how to find the constraints. Okay, we did that. So for example, if I want to say the constraints, so user constraints, describe that, describe that, okay? Describe that, the meta table, which will list all the constraints we have. Okay, so the first column is owner, who is the owner of the constraint, and then the constraint name. The owner is just like account user account owner, okay? Account owner. And the constraint name, constraint type, table name. So let's say if I want to look at a constraint name or type, then I will just do select constraint name, comma, constraint type from user underscore constraints. So that's SQL and run it. So we'll be getting bunch of constraints. A lot of them just not named or just just like artificially named by system. But some of them have named, so like a check age, like primary key, foreign keys, we just made. All those have names, okay? And then they will tell you what kind of constraint. So C means check constraint, R means reference, like a foreign key constraint, and P is a primary key constraint. So basically you have only 4 to 3 type of constraints, or 3 type of constraints, okay? All right, and then you can also look at which columns the constraint have. So for example, let's say describe user underscore cons and underscore columns. So that table, meta table, shows a relationship between constraints and the columns. So only few columns in this table. Constraint name, table name, and column name. So it tells you, which column, which constraint is tied to which column. So if I say select constraint name, and then table name, and then column name from user underscore cons underscore constraints. So that will give you the content in these 3 columns. Okay, so let's run that. Oh, something wrong. I misspelled something, I guess. So select constraint name, table name, column name, run user cons, columns. So columns. Okay. All right, so here, for example, primary key for tournament is for column AID, table is tournament. So basically this will give you which columns be part of which constraints. All right, so we did all that, I think. Now let's see what else we have done. Okay, so we're trying to change. Did we do this at all? We did not. So let's start with this one. Okay. So now suppose you already have a table. The table already have a data, and it's not practical to just drop the table and then recreate it. Make sense? Because you already have data in there. Okay. So very practical approach is you can change existing table. So for example, you may need extra columns, or you may need extra constraints, new business rules to be implemented, or maybe certain column size too small, you want to expand it. Okay, or maybe there are certain columns because that column is not going to be useful anywhere down the road, so you can delete it. Okay, so we are dealing with how to change a table structure by adding columns, adding constraints, drop columns, drop constraints, and also modify the columns. Okay, so I'm going to do a couple of examples. for each. First of all, let me look at just look at what we have, what we did today. Okay, so describe items. So items have description, minimum quantity, maximum quantity, color. Okay, that. Now let's say, suppose for the items, I need a new column. The column is, say, price, item price. Do I have price here? I don't, right? So how do I add the column? So you will do that. So auto table, the name of table, which is items, right? And then you say add. And then you have parentheses, close parentheses, and a semicolon. Let's do that first. And then inside the parentheses, you can list all the columns you want to add. So let's just add one price. Okay. For the price, let's say I want to do new number. Let's say 4,2. Okay. Let's say you can have up to $99.99 or $99.99 as the maximum price. So that is one item. We can also add more columns. Just comma and then add more. And then if you have a not null here, you can just say not null. That is okay. Okay. You can add constraints like that. Let's just try and add one more column for items. Let's just say SKU, description, minimum quantity, and item size, color, price. What other things you can add? I cannot think of anything easily. So let's just do this one. Okay. So let's add that, add one column and run it. So now this table has been changed. So if you just run this command again, not description again, you should see that the column price has been added. Okay. So that's how you can add columns to it. Make sense? Okay. Next, let's say how do we add constraints? So we'll do auto table items. Okay. Now let's say I want to add a constraint. What is a constraint? Let's just say the constraint I want to add is what? Let's just add a constraint. First of all, let's say price. Price cannot be negative. Okay. So even though price is set as number, right? It can be not null. But what if somebody put negative numbers? That does not make sense. So we can just make a constraint. Add, and then we'll say constraint. And then check price. Okay. And then we put a check and then parentheses, open it first, close it, open it first. Okay. So just make sure that all parentheses are matched, because otherwise you're going to forget which one was not matched, which was not closed. So just open, close, okay? And then check. So what we need to check is just make sure the price is greater than 0. So that is the constraint we want to add. Okay. And then let's run it. So let's take what the constraint has been added. Let's add one more. Now this time, let's say I want to make sure that the quantity must be between this and that, between minimum quantity and the maximum quantity. Does it make sense? Because you cannot have quantity on hand is smaller than minimum and bigger than maximum, okay? So let's just make sure that the quantity on hand must be between. So we add another rule, auto table items, and constraint. Okay, let's say let's check quantity on hand, okay? And then check open, close, and then close the whole thing, and then semicolon. And now let's put it inside here. Let's say what I want to check is quantity on hand between mean, the small one first, mean quantity, and the max quantity. So we can use between. So basically you can check the interval. Okay. Run it. So table has been updated. Now let's do one more. Let's say for this color, item color, let's say I only have like 3 different colors to choose from. Okay. Let's make the color to be only like available, can only have those one of the 3 colors. Okay. So we'll add one more constraint. More items. Add constraint. Let's say check color. Okay, so we check first. Close it. So what do we need to check? We need to check color must be in this list. Okay, let's create a parentheses first, and the list will have a list of values. So I'm going to, because they are text, so I'm going to put text inside a single quote. So the first one is maybe red color. Second one maybe white color. And third one maybe black color. So suppose I have only one of the 3 colors in the list. So this is how we check the list. So that just ensure that the color, when somebody enter a color, the color must be either red, white, or black. Otherwise, the record cannot be inserted. Okay. So let's run it. There we go. So all this has been added. So we learn how to add columns, add constraints. Right? So basically, just like when we create new tables and specify constraints, specify columns in the same way as if we create tables, but not just make sure that just not add new constraints or add new columns to it. Okay. Now, how do we drop columns? How to drop tables? Drop columns, drop constraints. To do that, you do the same thing, add the table constraint, add the table, and then you say drop. Okay, so when you say drop a column, now let's say which column you want to drop. Let's say I want to drop, say size, item size, okay? Item size. So let's say item size. So that's how you can drop that. So when you drop a column, just specify drop column, the name of the column. You do not need to specify other things, okay? So now the table has been added, so has been changed. So item size is no longer available. Okay, so how do you drop constraints? So now let's say I want to drop constraints regarding price. Okay, so remember we have a constraint called check price, right? So let's drop it. It's deleted. So drop at a table, items again, and then let's say drop constraint. The name of constraint is HK price. Okay, and we run that. Okay, so now this constraint is no longer available, is deleted. And this is how you can get rid of constraints. Even the constraint is just like a regular database object, but to drop the constraints, this is how you drop it. You do not have something called drop constraints and then the name constraints as a separate class. So basically you have to attach that to auto table as an option. Okay. So this is a very important drop constraint is a very important technique for database administrators. Often they need, for example, duplicate large quantity of data, they need backup data, or need to copy data from one place to another place. If there are so many constraints in place, this data duplication may not be possible because duplicating data will violate those constraints. So DBA will typically, what DBA will do is they will temporarily remove those constraints. Okay, drop those constraints first, and then after the data have been restored, whatever copied, and then you can just add those constraints back, so that in the future those constraints will be enforced. Okay, so this is how we drop constraints. Now let's say what if I have a situation like this? Say the description I put like a child 200, but then I realized that some descriptions are too long. They run in 500 characters. Okay, so then the 200 is not enough, right? So there's a maximum size of 200, and you can have smaller than 200. Okay, in that case, extra space can be saved. However, you cannot have more than 200 characters. Okay, so Then how do we make this change, make column change? So to change a column, you do the same thing. So add just elbow table items. And then you're going to use modify, okay? And then modify what? Modify the column. So just specify the column name, which is description, okay? And then you specify new data type and size. So let's just say I want to still use vocal 2, okay? And then let's just say I want to do 2000, suppose, okay? And semicolon. So modify, you can use auto, I think. So modify, then you specify column and specify new data type, data size. Okay, then you can change the data type and size like that. You can change data type. For example, you can change this to char. Of course, char you cannot have 2000. Char maybe just a couple hundreds. So for vocal 2, of course, you can do that. So now we have the table structure changed. Let us look at the description again. Describe items again. Okay, so now this description has 2000. Then remember size was deleted, price still here, okay? And now let's say I realize that the size 2000 is too big. I want to change it to smaller. Can I do that? Unfortunately, you cannot. Say it again. Auto table? What do you mean? No, you want to change column name? No, you cannot change column name. I cannot. So basically, the size. So if I make a size like 2000, suppose you want to change it to 500, you cannot do that. The reason for that is this modified column can only make size bigger. You cannot shrink. By shrinking, you're going to cause data loss. So you just imagine you already have data in the column and you shrink it, and it's very likely that you're going to truncate some data in there. So that's why shrinking is not allowed. Okay, so that is important to know. So you can only expand the size, but you cannot shrink the size. Okay. All right. Any questions? So this is just one slide showing, illustrated how do we use this. So let me see whether we move on. Yeah.
Can you show how to modify a constraint such as primary key? For example, I forgot to include department number in my primary key the first time.
Okay. So for that, you'll have to drop the constraint first. So let's just say alter table. Let's just say items. Okay. So remember the primary key. What's the name of the primary key constraint? So we'll say drop, and then say constraint, PK, and then items. Okay, we do not need a parentheses because we have one here. So
okay.
All right.
So you have to drop it and then add it again.
Then add it. Yeah.
Okay.
Something wrong? So I have some kind of error here. I think the unique foreign key is referenced by some foreign keys. Oh, I think items has a limitation because items was duplicated inside. So that is a little bit more complicated because the items was duplicated as a foreign key in another place. So we have to do what was checkout, I think, checkout item. So we have to do that first. Alter table, and then check out items. And then we say drop constraint, and then the constraint was FK, and then COI, I think, and then there was items, right?
Yes.
Was it? Let's delete that. So it's not right. So what was it?
Was it checkout item?
What is checkout items? That is the name of the table, right? And what was the name of the constraint for that table? The foreign key constraint. I forgot. Let me check. So let's say checkout items here. Checkout items here. Foreign key was item. Items. Item.
Oh, okay.
So there was I. So we need to get that constraint first. Okay, so that checkout has been changed, and now we can add. Just change this primary key. Drop the primary key. It has been changed. So now you can just go back to add a constraint and then add the constraint. So sometimes you may have just anything that related to changing primary keys is a little bit more time consuming, confusing. That's because those are so many integrity constraints, reference integrity constraints test. Right? So that's good. That's good because you know if you object, you can in case you make mistakes, then this will be just like a way to prevent from just those kind of accidents.
Thank you.
All right, and any other questions? Now let me see the slides, whether we have finished everything. Elder table, I'm just a few examples here. Remove columns constraints, change existing columns. Okay. Okay, so now let's have a few more slides to talk about other type of objects, Oracle objects. So the first one is a sequence. Sequence is like auto number generator. So if you had experience with Microsoft Access, your Microsoft SQL Server, they have auto number generators. So basically, so we insert the data into the column, which is like auto number. The auto number will be generated for you. Now you have the so where auto number will be like starting from 1 and 2, 3, automatically generated for you. So you do not have to enter those values manually. Okay. So how do we create that for Oracle? So Oracle is called a sequence. So let's try that. So create sequence. So then given name of sequence, let's say ID SEQ. Okay. So just a name. Okay, and then you specify what is the beginning number of the sequence. So that will say start with. Let's just say I want to start with 5. Okay, so the first number is 5. And then every time the new number will increment by a certain number, let's say increment by say 3. Okay, so then first number is 5, then 8, then 11, then what, 14, so on and so forth. So the number will look like that. Okay. So let's create that first. So the sequence is generated. Now let's see how can we use it. Okay. So to use the sequence, we'll just say select. The name of sequence is ID SEQ, and then say dot next value. Okay. And then from we'll use a virtual table because we do not have to use any object real table. So do virtual table. So now this time, the first time I run it, it will give me 5. Right? So if I run again, same command, give you 8. Do it again, 11. Do it again, 14. So that will guarantee that, when you generate this number, that number will be unique. So that will be very useful if you have some kind of table that require unique key values. So multiple people can insert the new records into it. Like just say we have travel agents, many travel agents doing travel reservations. And each time we have reservation ID, the reservation ID must be unique, right? So we have to make sure that everybody will get a unique ID. So that will be basically the way to do it. So every person just simply run this command to get a new ID, and that ID will be guaranteed to be across many different users. Okay. Now to drop the constraints, drop the sequence, just do say drop sequence, and then ID SEQ. So that sequence will be deleted. Okay, make sense? So that's how we handle auto number generators. And then let's continue. Not inside the create table, it's only insert table comments. When you insert a new real single table, then you can use that sequence to generate a new ID for the column. Okay. All right, now let's say, what about the, say I have a various complicated queries, and every time I may need to run many times, but I don't want to, just type all the commands or copy those commands all the time. So I can save those query as view. Okay, so essentially this is equivalent to Microsoft Access query. So when you use Microsoft to create queries, it's actually the query is saved. Okay, so basically here, so view is kind of equivalent to that. Okay, so let's say we remember we have let me do that. Remember we look at we use a query to find what columns has which constraint or tied to which columns. I think this one, right? This one. Okay. So suppose I need to run this. This query is not that complicated. It probably is okay to type every time, but so I don't want to say I don't want to say I don't want to run that copy this or type this all the time. So what I would do is I would just create a view for that. So say create view, and then name of view. I can just say let's just make up something. Okay, so my constraint column, my constraints. Just say my constraints. Okay, as, and then whatever query that you want to be saved. Okay, and then this query will be saved into this view. And then next time you just save it, simply just type, use this view to run this select statement. So let me create a view first. Oh, something wrong. Name already used. So let me change to something else. So let's say drop view first. Okay, drop view, and then my constraints. Delete the view first. Delete it, and now let's create it. Okay, so now let's start. So after I have that created, to some columns, I don't need that. Don't need it. Okay. Insert. Okay. So now let's say instead of running this select statement, type this select statement, I can just simply use this view. So this is what we do: select everything from my constraints. Okay. And then that would be equivalent to running this select statement. Oh, something wrong. I typed something wrong. Select from my constraints. What? Huh? I missed. Okay. I did not. Let me run it again. Okay, I see. So I was what I was running this one or this one. So make sure that your cursor is inside the column, inside that statement command. Okay, so here, so you see that we get exactly the same thing as that. So basically, from now on, this select statement is saved as my constraints. So in the future, you just use that view to run this select statement. Okay. Okay, so this is the view. How do we drop view? How do we delete? How do we drop view? How do we create a view? Okay, especially useful when you have very complicated columns. This will be this view will be very useful. Now synonym. Synonym is just another name for something else. Okay. Let me see. Suppose I have another user called Scott. Okay. He has a table called EMP table. Okay. And I need to use that table very often. So I want to create a synonym inside of my account. Okay. to reference to this synonym for this table, for this scouts table. Okay, so let me do that. So first of all, if I need to, I think everybody have access to Scout. I give a Scout table. Scout already give access to the public or his data. So if you want to select star from scout.emp, you should be able to get the data. Let me check. Yeah. So those are the data. Those are the employees. Employee records located in this table, EMP table, and that table belongs to Scout. Okay, so next, I do not say, suppose this is a very important table, I need to just create another name so that I don't have to forget, so I can remember all the time. I can create a synonym, create another name for that. So what I will do is we create synonym. Then the name of synonym, say let's say employees. Okay, for Scout.emp. Okay. Another table here, we have a table called users underscore counts columns. That is very, very long name. I can also create a synonym for that. Synonym. I think I misspelled synonym. Okay. Synonym. Okay. And then let's say that synonym is constraint. How do we name that constraint? Name that synonym. Let's just say I want to make sure that the constraint counts columns. Constraint columns. Okay, so let's just try to spell it out completely. Constraint column, let's say that's synonym for user underscore counts and underscore columns. Okay, so let's try that. So that is created. So after we have the synonym, and we can just run select statement against this, get data from this synonym instead of original table. So we'll say select. Remember what was it? Let's say constraint name, right? Constraint name from constraint columns. Constraint columns. Columns. Okay. So instead of using the original table, we can now use the synonyms for the original table. Okay, so now you can get the same effect. Okay, all the column names, all the constraint names will be listed from this table. Okay, so that's how we do synonyms. Okay, you can also drop synonyms, the name of synonyms. Okay. So drop synonym employees whatever. So here, so that's it, right? Very simple. Just create another name for another object, just in case you need to simplify all your names. Okay. Finally, you can also create database links. Database links is just say you have multiple databases and you need to access database, one in Africa, one in Japan, one in Russia. So you want to have a connection to those databases constantly. Sometimes you refer to those tables. So then basically just inside your account, you can just create a link to those databases, and then you can just refer and then get data using that link. So I'm going to show you one example. Suppose I want to create a database link. We cannot create this one. This one just basically is access. This all data, all parameters are correct. However, you cannot access to university Oracle server without going through VPN. But VPN, I realize is almost impossible to get connected. So we have to use eCourse. So eCourse does not have a connection to campus Oracle server because it does not have VPN either. All right. So So we can create a link to another, say, maybe to another eCourse account. And so now let's say what do we need to do? How do we create the link? So let me try the first of all. Let's see the last one. To create the link, you need to have three parameters. So you need to have host name, like that. You need to have a port number, and you need to have like a system ID. So service system ID, service name, all right? And then you also need to have a remote database user ID and a password. Connect to, identified by this password, this is user ID. Okay, so basically 3 server parameters and plus your own plus account to be able to access a remote database, right? So there you can create a link and then we can learn how to use the link, okay? So let's say I'm going to just copy this part, this description, because I do not want to type the whole thing again. And then we can make changes to access another database. So let's go back to here. So we'll do say create database link, okay? And then you create the link. So just say my DB link, okay? Or maybe you can just say this is Japan Oracle. So ORA Japan, okay? So just suppose this is the link for Oracle Japan, for Japan. Okay. And first you specify which account you're gonna connect to. So let's just say we have connected Scout, identified by the password for the Scout is Tiger, okay? And then you will say user, okay? And then single quote, and then semicolon. So using inside, you can have like a TNS names, or you can have full description. I'm going to get the full description here. So that's why we copy this one, copy the whole thing here. So just one single quote here, okay? And then just there's one here. Let me see what do we copy. So this is not there. So basically just anything inside the single quotes is what we copy, okay? And then we need to change the parameters. So for example, for eCourse, we still have to change it to eCourse.org. Okay. And then the port number is the same, we do not need to change. The service ID, the system name is actually OL7.eCourse.org. Okay. So by using this kind of description, you will be able to make connections to any database in the world, as long as they are not behind a firewall, okay? All right, so I'm connecting to Scout's account located on eCourse.org, and this is a service name for the database. So now let's try to run it, create it. So database link is created. All right, so now let's say how can we use it? Okay, so this is how we use it. We can just simply say select, or we can describe the table, EMP table at ORA Japan. So in other words, you are trying to get this table structure located in this database, located in this remote database. Okay. Says does not exist. Why? Should exist. Did I do something wrong? ORA Japan. ORA Japan. That's correct, right? Database link is correct. Object EMP does not exist. Cannot be true. Let me see. Select star one EMP at ORA Japan. Yeah, it is there. why this one is not working. So now let's see what are the tables it has. Okay, let's say select table underscore table underscore name from user user underscore tables at ORA Japan. So I'm looking at the remote all the tables in the remote database. So it has bonus, TPD, all that. Okay. And then why describe is not working? Okay, describe probably describe at ORA Japan. So maybe this one is not available for me. Oh, so the describe is Oracle plus command is not working for this remote database link. That's interesting. So describe is not working, but all regular SQL works. But this is describe. Describe is, remember, is a SQL plus command. It's not native SQL command. Okay, so describe is not working. Otherwise, it should be fine. Okay. All right, so if you want to get rid of the link, then just say dot database link, say ORA Japan. And this is SQL, so you drop that. Oh, something wrong? What is it? Database link, same name as an open connection. Okay, database has been connected, so it's not allow you to drop that. Open connection. Or a Japan. So because of this command is already finished. That's interesting, actually. Otherwise, we have the same as an open connection. Okay. So what do we do? So probably we have to exit and then come back to drop. So the database connection has to be closed, but there's no explicit command to close the connection. Okay, so anyway, so basically this command will be correct. It's just the database connection is still hanging on there. Let me see. There's not really a way to restore the connection. Okay. So let's say this will be the last thing. So basically for Oracle DDL, SQL DDL, we learn how to handle user accounts, how to handle tables, how to handle constraints, views, sequences, synonyms, and database links. Okay. And there are a few more things like triggers, like procedures, like functions. For that, we'll have to like write a PL/SQL code to do those, but we cannot do it today, at least. Maybe in the future. So in case if we have time, we can do those. But if we do not have time, then those things usually for this in this class toward the end we'll have like 2-3 weeks to do that. But this semester I want to cover MongoDB. For your knowledge, MongoDB is considered as a future Oracle. Oracle is not a future Oracle. MongoDB is the future of Oracle. Is playing very, it's non-SQL database. It's playing very important role for data analytics. Okay, so I want to save extra weeks for that. So basically, we may not have time to do this. So anyway, so the DDL we finish up to this point, and let's see what time is it? 8. Well, class ends at 9:50. Right? So we'll have 1 hour. So let's take a break first. Take a break until 822. Okay. Save changes. Resume. Okay, so we're back. So now let's follow the new slides on all the events. Basically, we need a few more, three more concepts on data modeling. We already did weak entities and associative entities. So we just need to add three more, and then we are done with all data modeling stuff. Okay. So we did that, right? We did this homework review. And then weak entities are basically just a way to handle multivariate attributes and also confusing concepts, basically. Okay, so if your student have multiple majors, you cannot create majors as attributes. So you have to make majors as a weak entity. If the employee has a multiple dependents, you have to handle that as a multivariate attributes too. So you include that weak entity. And a confusing concept like a book ID, so catalog a course, and the course the student sign up, that will be typically called like a class or section. So those will be handled by weak entities. Okay, so those are the examples. We already did that, right? And we also learned how to do conversions, right? So just make sure this little bar indicating that the primary key duplicated into the weak entity will be part of the primary key for the weak entity. Right? Then we'll have data on relationships. So a relation or data is basically depending on both ends, because in that case is kind of data describing the relationships. So in that case, you're going to turn that associative, turn the relationship into associative entities or gerunds. Okay, so we did that too. So for example, between order and the product. So if one order has multiple products, order the multiple products for that quantity. The quantity depends on the order, depends on the product. So you created a gerund in the middle. Okay, so get rid of that original relationship, original many-to-many relationship, and replaced by this gerund. So basically, original relationships becomes objects here. Okay? And similarly, between student and class, say we want to have a student grade recorded. The student grade depends on the student, and also depends on which class the student takes. Right? Depends on both. So therefore, the grade is actually data for the relationship. So we're getting rid of the relationship and replace that gerund by the associative entity. Okay. And what about relationships among things inside the same box? Let's say that just think of an example here. So we'll have employees, right? Employees have managers. So basically, you're talking about the managers and the employees have relationship. Or the managers, who are managers? The managers are employees themselves. Managers are employees, right? So instead of creating two boxes, one for manager, one for employee, then it makes more sense just create a relationship between employee and employee. So let me just use what? So there's a white box, there's a whiteboard to do that. So let's see. Create a new one. So let me explain that using whiteboard here. So we have employee here. The employee objects of employee ID, identifier, employee last name, required job title, original, okay? And then, so then we just say we want to find out who are the managers of employees. Managers are employees themselves. So instead of creating, say, another box for manager, the manager will also have employee ID, employee name, also have a job, also have salaries. So anything that employees have, managers also have. So then you just simply say you're creating duplicates, right? Duplicates are not good. So this is really, this is just kind of like just same thing as this employees. And then if you think of which manager, which employee is managed by which manager, the relationship between them, right? So now just imagine that you combine these two together, then you have a relationship between employee and employee, so that you don't have this anymore, right? So then you just say this relationship is kind of relationship tying, connecting employees with employees. Okay. And then you can just imagine, this has two ends, and this end is a manager, this end is the employees. Okay. So then you can also put like a cardinality or the optionality. So one manager can manage how many employees? Many, right? Let's just do many. Many. And then one employee is managed by how many managers? Just one, directly, right? The direct manager, just one supervisor. Okay, so that's a one-to-many relationship. Okay, and then what about optionality? For optionality, you do not need to think. You do not need to think. They are always optional to optional for recursive relationship. Okay, so you can just think about outside the class. So what if it's not optional to optional? If it's not optional to optional, the consequence will be something like that. A manager is going to be manager of his own. A manager is going to be a manager of his own. So that is not possible, not practical, right? So this is how the recursive relationship is used. So anytime we have relationship that ties objects inside the same kind of objects, then you're going to use recursive. Then the question is, when you have this kind of relationship, this kind of ERD, how do you convert to relational model? So the relational model, you're going to convert in the same way as before. So you can create employees table. Okay, so that has employee ID, employee last name, and employee job optional. Okay, so create as normal. But then you handle relationships. The relationship is one to many. So you're going to duplicate the primary key from one side to many sides. So one side is employee, so the employee ID is going to be duplicated. And the many side is also employees. So that means you're going to duplicate that inside the same table. So you're going to duplicate the EID also here. But then, of course, you cannot have two column names identical. So you have to change this. Maybe this change to manager. Change to manager. And then this is going to be a foreign key, duplicating this one. Okay? Is that foreign key required or optional? Duplicate here. Dashed, right? The receiving side is dashed, so this foreign key is optional. Make sense? In some stupid textbook saying that foreign key is primary key coming from another table, but this is not true. That's not the correct definition. So in this case, we have foreign key coming from the same table, not from another table. Okay? So just generally, a foreign key is a duplicated primary key. Does not matter where it's duplicated. It could be in the same table, it could be in different tables. Okay? Is it clear, everyone? Now let's find another example. Let's just say I have a situation that I have a course, catalog a course. Okay, the course will typically have a course number, title, and then credit. And what about the prerequisite? What about the prerequisites? So it's tempting to do something like this, create another box called a prerequisite. Prerequisite. So what are the prerequisites? They are just courses. So they will have a course number, they will have a title, they will have a credit. So everything that just, the prerequisite is just like courses. Same thing. So if you want to have a relationship between course and the prerequisite, essentially you are doing like a recursive relationship between course and the course. So then this one is not necessary. Get rid of that. Okay. And then in this case, so just imagine this side is a course and this side is a prerequisite, and then set up cardinalities. So one course may require multiple courses as a prerequisite. So one course has multiple prerequisites. And one prerequisite can be prerequisite for multiple courses too, right? So this is many-to-many situations. Okay? Does it make sense? So one course may require multiple courses as a prerequisite, and one prerequisite can solve as prerequisite for multiple courses. All right? Optionality, again, is always optional to optional. So let's make that dashed. Okay? So now let's say in this case, how do we handle the relationship? How do we handle the conversion? So we're going to do the same thing. So we're going to say the courses. It has course number, ID, title, required, credit, optional. And then we have a many-to-many relationship. So when you have a many-to-many relationship, you need a junction table. So you need to create a junction table in this case. So junction table is going to duplicate primary key from both ends. So one end is a course, that is course number, so you duplicate the course number. And that is one foreign key. The foreign key will be always required in junction table, right? Okay. And then other end is still course number, still courses. So still this primary key. So you're going to duplicate this course number again. But of course, you have to change the name. You cannot have two names identical, two columns have identical names. So we can change this to maybe called as a prereq. Okay. And then foreign key, and that's also required. Okay, and then we can also make these two columns to make one composite primary key like that. So that's how we need to handle recursive many-to-many relationship. Okay, so there are many such examples. In the production settings, you have products which made of other products, parts made out of other parts. So in that case, you also have relationship between parts and parts. Okay, and in the store, in like a retail settings, you may have like a products be bundled together. So one product may be bundled with other products. Okay, so in that case, you're talking about one product, connected with other products relationship, right? Still one more example, say in retail settings, you create an order, and sometimes the order cannot be fulfilled right away. So you have to create a back orders. And the orders and the back orders, they're all orders, right? So you basically essentially need to keep track of the relationship between order and their back orders. So one order may spawn off multiple back orders. So again, that's all relationship between orders and orders. Okay. So this recursive relationship is just like that, very common. All right. Okay, so start run the slides again. So we have a path, assembly path. Also, there's a case here like in flights. So often, you board the flight number, and then when you go to the terminal, you found that is labeled not only the flight number you purchased, but also some other kind of flight number. So often this airline industry have like a so-called code share, right? So one flight may be labeled into different flight numbers. Okay, So different companies may share the same flight, attach a different flight number. So in that case, the flight and the flight, all the flights, they share the same code. They share the same flights with different code. May be also related together. So using this recursive relationship. So here are the examples: prerequisite case, manager case, and the flight sharing case, code sharing case. Okay. Now, can we have entities that are almost identical except that a few differences, very tiny differences? So we have example like that. So we may say just all the employees, okay? All employees going to have employee ID, employee last name, first name, job. Okay, there's a lot of other like address, all that very similar. However, there are tiny differences between part-timers and full-timers. What are differences? The part-timers have wage, but the full-timers have salaries. Okay, so in those cases, what we could do is we will create a bigger box called silver type for all employees with all the common attributes. And then we only indicate the differences with part-timers and the full-timers into the sub boxes. Now let me show you how we do that, okay? Let's see, go into the slide again. Okay, so how do we do? So let's just say all the employees. So all those common attributes will belong to those all employees. So they will have employee ID, employee last name, employee first name, employee job, and maybe this is required, this is optional, and maybe phone number. So all these are common, okay? However, there are only small differences between part-timers and full-timers. So I am going to create just smaller box for those special situations. So this will be called a full-timer, which have say salary. And then we have part-timers. Which have wage. So all the full-timers, part-timers, they share the same attributes, common attributes. Most of them the same, but except these minor differences, right? So we call this a sub type. And then the bigger box or the silver type. Okay. So this relationship is what is like a you have a bigger group, all employees, and then you put employees into different groups, subgroups inside. Okay, so some of them full-timers, some of them part-timers. You create a small group inside a bigger group. That's what it does. Okay, but make sure that you're using this concept correctly. So the way to test whether you're using it correctly is this. You check, say, is a full-timer or employee? Is a part-timer or employee? If answer is yes, then you use it correctly. If not, you probably made a mistake. So let me give you an example. So we have sometimes we have people doing this. So there was a customer, and the customer have a customer ID, customer name. Okay, and then the inside here they create buy and sell. Okay, so when you do that, you have to be very clear whether you use this subtype correctly. So the way to test is it buy or kind of customer? Is it sell or kind of customer? No. None of this is correct. So then this is incorrect. This is incorrect use of the subtypes. Okay. However, if you change this, if you say this is a buyer and this is seller, then that might be correct. Right? So buyer is kind of customer, yes. Seller is also kind of customer. So for example, if you're dealing with eBay, then that's probably right. Buyer is a kind of customer, seller is kind of customer. Does it make sense? But if you just use a buy and a sell, then this will not be correct. So let's make sure you do that test, okay? And now let's say if you have this kind of super type subtypes, how are you going to convert into relational model? How are you going to convert that into relational model? And to do that, this is what I will do. So there actually in my book, I introduced 4 different ways to do the conversion. So there was something called supertype implementation, subtype implementation, explicit and implicit subtypes. But then there's the one implementation I like the most is called arc implementation. Arc implementation. Okay. So that's the one I want to introduce. I do not want to spend so much time talking about other 3 implementations. So let's talk about how we do that. Okay, so first of all, using arc implementation, you're going to create one table for each box. Does not matter if small box or big box. Going to create one table for each box. Okay. So first one maybe called 4 tables. So at this point, 4 tables has only salary column. And then you create the same thing for part-timers. The part-timers have a wage. It's also optional. And then you do the same thing for silver type. So silver type is called employees. And then we'll have employee ID. What else? Employee last name, first name, job, and phone. Employee last name, employee first name, employee job, or and the phone optional. So that is a very simple step, just like what we do with any other entities. Just create one box for each entity. Okay. Next step, second step, very important. Just remember, if that sub box or silver box has its own UID, use that UID as a primary key. So, for example, employees have a UID, so we underline that, make that be primary key. Okay. And what if a box does not have UID? Small box, bigger box. What if it does not have UID? Then you need to create artificial ID, artificial key for the table. So 4 timers does not have ID, so I'm going to create one. So I'm going to make that as FT ID. And that is artificial key for that. Okay. And then part-time ID, part-time also does not have ID, so we're going to create artificial key also. Let's call that KPID. Okay. And the employees, if it does not have ID, then you do the same thing. Since we already have ID, then just use this ID as a primary key. Make sense? So that is just make sure that create artificial key for a table that does not have IDs. And next, the third step. The third step is a very essential. That is to duplicate the primary key from sub-table box, sub-tables into the silver table. So you're going to duplicate the FT ID and the PT ID into the server table, into the employee table. So FT ID has one foreign key, and that foreign key is always optional, always, okay? And then PT ID, that is also optional, you duplicate it here. So if you're trying to see that the image, what the connection looks like, that is mapped to here, and that is mapped to here. Okay? So duplicate the primary key from subtype tables into the server type. Now let's just imagine, let's try to create an employee. So let's say employee, let's say have employee ID 1111111, okay? Employee last name is Bill, and this is John, and job is say salesman, and the phone number is 1111111. Maybe there's one more here, 111, okay? And then suppose that employee is a part-timer, then he or she is going to have a part-time ID in here. But then he will not have a full-time ID, so this place will be empty. Make sense? So if you do another employee, you do two, let's say this is Smith, and this is Lisa. Suppose she's the manager. And let's just say her phone number is 222. And then suppose she is the full-timer, so she will have a record here, but then she will not have a record here. Okay. Now, do you say that these two columns are exclusive? Only one of them can have values, right? So essentially, these two relationships are exclusive. So you can have like an arc here. Okay, so that's why this is called arc implementation. Okay, this is arc implementation. So arc implementation, when you have arc, it means just the relationships are exclusive. So if this relationship is true, then other relationship must be not true, and vice versa. Okay. All right, next. Let me go back to the slide. Go back to the slide. So we have examples. We have a couple of examples here, the part-timer, full-timers that I just explained. And the customers, you may have corporate customers, individual customers, right? So that is also kind of a subtype, right? So all customers, and they all have like a customer ID, customer phone number, email, user ID, password, the common attributes. But then corporate customers will have like a company name, will have like a contact name, and the individual customers will have a first name, last names, right? So they basically will have some little bit difference. And then account, like checking account, savings account, all the accounts have numbers, account number have balance, all that. But then checking account, we have like a, say, quota on how many checks you can write per month, you can clear every month. Or for savings account, you may have like an interest rate. The checking account does not. So there may be some other attributes some attributes that will be different. Okay. So here are just demonstrations of how those are related. Okay. So customers, corporate, individual, or products. It may be perishable products, which is kind of like a products. Okay. So in this case, we just differentiate just one small group, subgroups, and then others have a bigger group, which is all regular products. But then you have just one subgroups, perishable ones, which have special attributes. So everything else. So basically, in this case, we're assuming that all products have the same kind of SKU description and price, except that for perishables, you will have like expiration date, extra column. Okay, so So subtypes does not have to be just all exclusive, does not have to be complete. You can just have one subtype or two subtypes. Okay. And in here you have subtypes that may be also connected. For example, checking account, savings account, they themselves may have been connected. For example, each checking account may have multiple associated savings account, right? So this is representing the associated or linked savings account relationship. Okay. So subtypes can be also connected to other things as usual. Okay. So I told you that there are some bad examples here. So for example, we have department and put staff as subtype. So you check is staff kind of employee department? No. So this is a common mistake. So you think that department has staff, right? So you put staff as subtype. That's not the right use of subtype. So correct use is some small group must be special kind of departments. Special kind of departments, not a staff. Okay? And other things like reservations contains books. That's also a bad example. So book is not a kind of reservation. Okay. All right. So sometimes you may be fooled by the names. So for example, inpatients and outpatients, are they subtype patients? What do you think? Inpatient, outpatients, are they just special kind of patients? What do you think? That is you may be fooled by just names here. So why? This is what you have to consider database design for long-term use. So if you design a database like for clinic or for hospital situations, you're going to have patients. Okay, so patients are going to have patient ID, patient name, all that. But then whether the patient is inpatient or outpatient depends on the time the patient visited you, right? So maybe that one patient can be inpatient one time, but outpatient some other times. Does it make sense? So today you may be inpatient, but tomorrow you may be outpatient. Okay, it's the same patient. Okay, so what is the correct use in this case? So correct use, you should use inpatient, outpatient for visit, for the treatment, not for patient classification. So in other words, you should classify treatments as inpatient treatment, outpatient treatment, but not classifying patients as inpatient or outpatients. Is that clear? Okay. Then another thing is customers. Customers classified as buyers and sellers. Appears to be right. However, you have to think carefully. One customer may be selling at one time and also buying some other times. Maybe same account can do both, right? So you may not be able to classify your customer as a buyer or a seller just that cleanly. So what you should do instead is you should treat all customers as customers. Does not matter what they do. Okay, it's buyers or sellers, but you just treat transactions, different transactions. There's some transactions may be selling transactions, some transactions will be buying transactions. So then basically it does not matter whether the customer is doing buying or selling. So basically the customer is doing transactions, and the transaction has two types: buying, selling. Okay, does it make sense? So make sure that it's just because basically by the type, by the check, by say staff is kind of department. No, you think that's the way to check to see whether it's correctly used or not. So basically, conceptually, that is a way to check. However, sometimes like this, you have to think, you have to put that concept in the context and make sure you use it to satisfy the practical data requirements, the data needs. Okay, not just conceptually is correct. Conceptually, yes, inpatient, outpatients are kind of patients, and the buyer sellers are kind of buyers. However, by doing that, you are creating a database which may not satisfy the customer needs. Okay. All right, so this is what I was suggesting. So just create a visit, and then you have inpatient visit and outpatient visit. And transactions, you have buy-ins and sell transaction, buy transaction, sell transaction, and buy transaction. So buy is kind of transaction, sell is kind of transaction. That's correct use. Inpatient visit is kind of visit. That's correct use. Okay. And finally, we have one more concept to go. Let me see. I should hope I have enough time. What time we should? Okay, so we still have like how many minutes? 15 minutes? Okay, so we probably should be okay. So the last type of last concept is called exclusive relationship. So when you have a relationship cannot exist simultaneously, cannot hold simultaneously, that is exclusive relationship. So two relationships, only one of them can be true, other one cannot be true at the same time. So let me give you an example here. So suppose I have a staff, okay, employees, the part-time employees, full-time employees, right? And then they will be assigned to office, right? Okay. So how are they assigned? Typically, one full-time employee will occupy one office. Okay, one office for one employee and one employee for one office. And for part-time employees, they typically share office. So one office may be shared by multiple employees. Okay. However, these two relationships cannot be satisfied at the same time. Why? Because if office is already assigned to part-timer, then that office cannot be assigned to part-timer, and vice versa. So these two relationships are exclusive. So that's why it's called exclusive relationship. Make sense? Now here is another example. So when you visit a doctor, you're going to file claims, right? So sometimes the clinic will file a claim for you. Sometimes the clinic will not do that, but you have to do it yourself, and patient can file claims. Okay, however, in this case, each claim will be either filed by patient or by clinic, but not both. So that's why this relationship also exclusive. Make sense, everyone? So claim is either made by patient or by clinic, but not both. So these two relationships are exclusive. Good. And the conversions, we already did the weak entities, associative entities. Okay, so for example, for this gerund, we already did that, right? So we'll just skip that. And then for this many-to-many relationship, conjunction table. For supertype implementation, subtype implementation, I'm going to skip all that. Okay, so we don't care about this. It's just this with arc implementation. Three steps. Okay, and make sure you remember the 3 steps. All right, so this is an example for that. So actually, when you do that, you're going to get this kind of arc relationship. So that's why it's called arc implementation. And for exclusive relationship, generally for exclusive relationship, you have to write complicated PL/SQL code to implement those. But in special cases, if you have just a one-to-many or one-to-one relationship, and if the arc side is a side receiving foreign keys from other connecting entities, then you can implement that. But otherwise, you cannot. Okay. So let me show you. Let me see where I have that. So here, there's an example. So suppose I have employee and shipment. They both have address. So one address could be either for employee or for shipment, but not for both. Right. So in this case, you're going to duplicate the primary key from shipment into here, and for employee into here, and then these two foreign keys will be exclusive. One of them can have value. So therefore, only in these situations, that the receiving side is the arc side, all foreign keys will come to the arc side, then you can write code. Okay. So what I'm going to do is I have 15 minutes, so I'm going to so we do not have time to do complicated things here. So what I'm going to do is to show you how to draw the model. So let's create a data model first, okay? And then write a code for arc implementation. Okay, so let's go to subviews, new subviews. Okay, and then let's say I am going to create customers. Let's put a couple of attributes. Let's say customer ID. And let's say that is char. And let's say that is 11 characters. And that is ID. And the ID. Right. Let's do one more. Let's say employee customer name. So customer name. Maybe last name. Okay. And then let's just say the char. And then let's say that is 45 characters. And suppose that's required. Okay, so we have a customer. Now let's say I will have two. Hold on. For customers, we want to do. Let me just do that first. Okay, so let's say corporate customer. Corporate. Okay. And then for corporate customer, let's say we have a customer. We have company. And then company has a name. Let's just say that is 25 characters, and that is we can make that as ID, primary ID. Apply, and then let's make one more. Let's just say contact. Okay. So contact. Let's say that's the char, and then let's say that is 45 characters long, and maybe optional. Okay. So now I want to make a corporate customer as special kind of customer, a subtype. So I go to general, and then you select super type here. Apply. So now you see that. Okay. So if you're going to make the link, make the box bigger, and select inside and move around. So you create a sub box like that. Okay. And let's do it again. Suppose I also have individual customers. Let's say individual. So for individuals, let's say we have attributes like the last name, 25 characters. Okay, let's just say this may be required. And the first name, let's say that is char, 45 characters. Also, let's say required. And now let's make individuals also a kind of customer. So we select super type, which is a customer. Okay, now we have a second box inside. Okay, does it make sense? So that's how you can draw subtypes. All right, so now let's try to draw one more thing. Let me say auto. Auto. And then let's say auto have attributes like OID, char, 15 characters. And let's say this primary ID, apply. Go to one more, let's say auto date. As you go with the date. And let's say this required. There we go. Okay. So then the customer will make orders, right? So now let's say, hold on, I'll cancel that. Let's say we have a back orders. So I'm going to create a recursive relationship. So for back orders, I'm going to use any relationship and we click inside and click inside again. So create a recursive. So let's say back order. Right? Back order, right? So let's just imagine this order and this is back order. So one order may spawn multiple back orders. And the one back order is coming from one order, right? So that's one. Okay. And the relationship is always optional to optional. So select optional. There we go. And then so you have created this relationship. Now let's just For exclusive relationship, I'm just using the, I'm not, this may not make sense, but I'm just trying to make use this one to show you how do we do that. So I'm going to say part-time individuals and the corporate, they all make orders, okay? So let's just use this one-to-many here, cost individuals, and create, can make orders. So one individual can make many orders, and one order is made by one individual. And then order side will be required, or if you have order, then you definitely have a, no, not, it's optional. So order may be ordered by corporate, not by individual. So it's optional. Individual may or may not have option, may or may not have order, so that's also optional. Okay, so let's just say both sides are optional. So let's do it again. Let's say we have another relationship with the team, corporate, and orders. Okay, so let's say that is also takes. So one corporate can take many orders, and one order may be taken by one corporate, and then both sides will be optional. Order may be taken not by corporate, instead by individuals. So this is optional, and the corporate may or may not take orders. So that's optional to optional again. So now let's say, how do we draw this arc? How do we make this relationship to be like an arc, to be exclusive? So in a sense that order can be either taken by individual or corporate, but not both. Okay. So this is what we do. We select a relationship, hold your control key, select second relationship, and then select the site that you are going to put up. So this is site. So that, and after that, you see that arc will appear here. So this arc, so you create arc. And that's how you can create a relationship. Oh, this is kind of an arc connected there too. So this is not correct. So now let me see. How can I get rid of that? So I'm going to select this relationship and then select the arc. Select this arc. Is arc selected? And then you see that there's a remove arc here. Is that remove? Yeah. Okay, so now the arc will be out of this relationship. So only tied to these two relationships. Only these two relationships are exclusive. Okay, so this is how we use data model to draw the three advanced concepts. Okay, 4 more minutes left. And let's say how can we implement, how do we write SQL? So let's go back to SQL Developer. Where is SQL Developer? SQL Developer. This is another one. I hope I did not close it. And this is another one. This one, okay. So let's create. I'm going to just show you how we're going to do the arc. Okay. So let's see. We have this whiteboard here. So let's implement this one. Full-timers, part-timers, and then employees. And now we see these two are in the arc. Okay. So I'm going to just implement that one. And then move this up, and then let's create table one by one. First of all, create table without the foreign keys first. Okay, create table full-timers. Okay. Symbol just have salary. And let's say salary is a number, let's say 7,2, and which could be mouse, could be missing values. And then FT ID. That is, let's just make up something here. Let's say this number 5, okay, full-time employees, okay. And then we just make a constraint, PK, FT, then say primary key, this is FT ID. Okay. Finish it. Now let's create a second table, create table, part-timers. So that's pretty easy. So it's weight, so say there's a number, maybe 4,2, and then PT ID, let's say that is a number, 3 digits number, okay? And now we create a constraint. Constraint pk, and then let's just say that is pt, primary key, and then primary key is pt id. Finish it. So those are just normal. And now let's just come to the essential ones, see how we're going to create table employees. So let's do that. Create table, employees. The employee table have EID. Let's just say there's a number, maybe 7. Okay. Come on. Employee last name, name. And let's say there's a char, 45 characters. And that's not null, not null. Okay. And then first name, EF name. That's also char, 45. And that's also not null. And then job, char, 25, which is optional. Phone, and then char, 14. That is also optional. And then finally, FT ID. Remember that is just full-time ID, so we have to make sure that is using the same data type and size. So that's number 5. Number 5. Okay, that's optional. And do the same thing, PT ID. That's number 3. Okay. And then rest will be just doing the constraints. So constraint PK first. So PK for employees, then the primary key, and then the EID. Okay. All right, and then we do foreign keys. There are 2 foreign keys, constraint, FK, EMP. First one to FT. Okay, so that's just a foreign key, and then that is FT ID. References, full numbers. So the same thing, constraint, FK, EMP to part-timers, foreign key, and then we'll do PT ID, and then references, and part-timers. So all these are usual, right? All these are nothing new. And now let's say, how can we do that? These are. So make sure that only one of them can have values. So we have to do another constraint, check constraint, check, say check out is the name. Okay, so we say check. And then we put a parenthesis first. Okay, and then we go to the end, say parenthesis, close. Okay, but now we are going to put optional check inside here, this parenthesis. Okay, so I'm going to put multiple lines here. Leave that in the multiple lines. And so I'm going to first check if FT ID is null, then the other one must be not null. So and PT ID is not null. So this is one case. Or let's do the opposite case. FT ID is not null and PT ID is null. So this is how we implement exclusive relationship here. So we just basically check if this one has a value, has no value, then the other one must have value. Okay, or opposite. All right, is that clear? Okay, so I used extra 2 minutes. Sorry for that. Trying to give you extra minutes, 2 minutes back next time. All right, does anybody have questions? Questions, anybody? Now let me go into stop recording.